In our next session, we will be discussing the challenges of the product development and creating new products for the markets. But that will be a view from a experienced and very successful SME point of view, but also we would like to bring in the view from the academia, how academia and how academic research can enable that innovation for product development to take place. So I would like to invite Managing Director of the MJ Products, Mark Johnson, and Dr. Rob Thornton from University of Leicester Engineering Department for the discussion. So before I just jump in, if the attendees can also join in the conversation by going into the slido.com and then enter this code 673210, they can then join us by voting for the polls during the session that we will be bringing during our conversation. So that will greatly help us directing the panel in terms of answering the particular questions in the attendees' mind. So I'll just leave it for a second in here. So that's Slido, and we can also put this one into the chat as well. Okay, so without further ado, I will just want to open up the conversation for our panelists. Okay, so Mark, Rob, so thank you very much for joining us today. So can we just briefly start with a quick introduction from your side? So can you just introduce yourself, your role, your products, what you do? So that would be a great start for us to get into the discussion.
Okay, good morning, everybody. I'm Mark, obviously, and a bit about myself. I started life as an apprentice in engineering, went on from there to university, studied manufacturing engineering for 4 years, and then subsequently worked in engineering in different companies, different industries, proceeded into sort of operations management, and then was very fortunate to then work within an organisation on a startup with very innovative products, which was a tremendous experience for myself. That culminated and led to me eventually then starting my own business about 11 years ago. I identified an opportunity in the market whereby lifting equipment is commonplace for pallets using forklifts and tail lifts and cranes and various other pieces of equipment that we all know about. But there was an obvious gap, or seemed to be a gap in the market for lighter weight devices for lifting lighter loads and sort of accommodating and overcoming manual handling issues, which are becoming, more and more prevalent in today's industry. And so I set up a company specifically to manufacture this lighter weight handling equipment. We developed a pump technology which we patented back in 2010 called Duo Pump, which is the ability to use manual power, but to be able to lift very quickly when there's a light load to a height, and to be able to then change gear automatically to lift heavier loads so that you can get up to a load very quickly. And our initial success culminated in quite a major project to supply the whole of Dunelm Group with lifting equipment that's safe enough for them to bring goods from the back of store, destack it very quickly, take it into store, and to put it straight onto a shelf. And if you go into any Dunelm store, you would see quite old looking versions of that equipment now, because many of the original ones 10 years ago are still in daily use today. And then from then, the company's innovated into lighter and more portable products of different ranges in the same sort of technology that the original product was.
Great, thank you, Mark, for that very good description of your product as well. I'll ask further questions about your product, your journey, but before that, Rob, can you please introduce yourself as well, please?
Absolutely. So hi everyone, I'm Rob Thornton. I'm a chartered mechanical engineer and also the Director of Learning and Teaching in the School of Engineering at Leicester. So in my case, my sort of life started with a degree in mechanical engineering at Sheffield University, followed by a PhD looking at novel heat treatments to make stuff last longer from a tribological perspective. So that's friction and wear and lubrication. And I've been at Leicester since 2014. So I came down here to get a proper academic job and have been working here ever since. Along with my colleague Dave Weston, who's also on the call today, we are very keen to expand the amount of industry academic links that there are, and that's at every level. So today I'm probably particularly going to talk about opportunities that there are for industry to work with universities through student projects. But that's really just the start of what could be a very long and positive relationship that will expand into perhaps knowledge transfer partnerships and potentially into larger grant applications as well. So there's lots of different areas that universities can contribute, both from the point of view of academic staff and our students, who are a fantastic resource in themselves.
Definitely. So thank you, Rob. I don't think that this will be enough to cover all the great things that you have done in the past by collaborating with the industries, but we'll definitely share the link of describing that. So Mark, considering that we are discussing the product development, I'll just want to come back to you on the particular question about your product, the van-made product. So you briefly described when it started, how it's been developed, but I just want to understand basically what were the key steps that you had to take? What were the key challenges that you have to just tackle while developing this particular product?
Okay, so obviously we'd had a number of years experience with developing lifting equipment that was lighter, easy to move around, easy to use and operate, intuitive effectively. And we identified that there's a real opportunity in the market to take that technology to make it even lighter. And we were demonstrating another piece of equipment at a quite large blue chip UK customer, and they were lifting products from a van. Mm-hmm. And you know, to me at the time, not obvious to everybody, but to me at the time, it was obvious that we needed to evolve our product and our technology to make it so light that it was portable. That equipment can then be placed into a van and used to make deliveries. And so it wasn't called VanMate at the time. It had a prototype name called Bertie. It was Project B. But that product became a much lighter version, an evolution, although a step change in what we'd been doing for 7 or 8 years. And the challenges in that development, having learned through the sort of difficulties and challenges that we overcame with the dual pump system many years before, the challenges with VanMate was to take the product, to make it even lighter, to make it manufacturable, to improve the manufacturing of it, and fundamentally to be able to take it apart, to be able to take a structural product that needs to meet these regulations that Howard referred to earlier, which we do, and to structurally support a load, but be so light that you can pick it up. Mm-hmm. And the challenge at that time, it's different now with the support we get from universities, but at that time the challenge was that as an engineer, the first one you make and the first one designed, it worked because that's what engineers do. You just couldn't pick it up, and so the challenge then became, you know, designing a product that was modular and you could take apart was an engineering challenge, and we overcame that. The next challenge then was to actually look at where we can take the weight out of the product and where we can simplify its manufacture and get it to a point whereby if we're going to sell a piece of equipment that's for manual handling, the equipment itself is not so heavy that it's unsafe to manually handle. And that was the biggest challenge. I think moving forward, that challenge never ends because we started with vans. And now we've got, you know, hundreds of these systems in the UK and distributors being set up overseas. The biggest single use in the UK is for lifting oil drums and engines and gearboxes out of the back of small vans and making deliveries to garages. But over time, what's becoming more exciting recently is that we've got inquiries now for retail, and retailers have lorries, and they're looking at the product for making home deliveries of washing machines and fridge freezers and treadmills and various other sort of home products, because the product is significantly lighter and less expensive than a tail lift. And unlike a tail lift, the product can deliver the goods to the door. But the challenges we face with that is that customers and the market demands a product that can lift higher, it can lift more weight, and they want it lighter. And so technically that's where we need to really push the sort of science of what we're doing to stay, you know, to keep optimizing the development of the product.
Yeah, So you are emphasizing more about the current development and the innovation of the product at this moment in time. Okay, I'll ask the question again for the audience right now. So if everyone can go to the Slido page, then I'll just open this up and then I'll ask a question to the audience considering what we've been discussing regarding the product development journey and also the challenges. So if you can go to Slido, the page that you have opened, and if I can ask the audience to answer which of these listed processes that we have highlighted before are the most challenging ones for your sector. And that will help us a lot in terms of the upcoming discussion about where innovation can happen, what are the main challenges within these areas. So while this is being populated, I think there could be a clear winner in here. So what are your views, Rob and Mark, on this? So from your point of view, Mark, is that the case? Or Rob, what are the things that you see from the industry relationships?
If I may, it was quite interesting to see. I actually put on their design, because we're a leading edge in terms of product and innovation and sort of making products lighter weight. But I suppose looking at those results, and production's quite high in prototype development, but I suppose from my point of view, my background is that, you know, I graduated top of my class in manufacturing engineering, so design for manufacture and production and processes, I can do in my sleep. It's not a problem. It's actually getting the concept to a manufacturable stage, which is the design element for me. And thinking outside the box, it's very challenging sometimes to run a business and to iteratively develop products, and then to be able to take a step back and reconceptualize the next generation, which I think Howard referred to previously about, you know, sometimes you can pursue revising existing designs and not take the step away from that and say, is there a different approach, is there a different material, is there a different method altogether? And so I think people will view it differently depending on their backgrounds. A design engineer would probably say production's a challenge, where vice versa for myself.
Yeah, I think that depends on what we have as the audience right now, but considering that the manufacturing is a key area that the local economy is focusing on, production challenges of developing, of improving, that could be the case. What are your views then, Rob? So what are the relationships that you have with the companies expressing more interest in terms of further development in the key areas?
So I think there's probably two key areas where we commonly see companies approaching universities or approaching us for sort of specialist advice, and they tie in quite neatly with really the expertise that's either offered by sort of experienced academics and researchers, or indeed the capabilities that students have. So on the academic front, we commonly find companies are very interested in learning about some of the latest academic research or new techniques or new processes that are being developed and being tested. So these are things that we as a university can prove work on a laboratory scale, but we don't have the scope to scale these things up and to sort of put them into larger scale production. So a good example of that is actually a recent project that Dave Weston has just about come to the end of, where Dave has been working with industry to try and scale up a novel electroplating process that Dave himself has developed over many years. And this electroplating process allows Dave to create nano composite coatings and potentially tailorable with very wide sort of varieties of different materials. So you can have very good wear resistance, or you can have very low friction, or you can potentially give it other sort of positive characteristics as well. And so Dave has been working on an Innovate UK funded project in that area, which is really a knowledge transfer project in many respects. Then the other area where we commonly sort of work with industry is in their particular sort of developmental challenges. So it may be that we're talking about a new startup who has a design idea, they've got a concept, but they don't necessarily have the in-house skills to develop that in terms of doing the fundamental calculations, in terms of generating the CAD models and some sort of basic prototypes. And that's something that's the kind of activity that engineering students, third and fourth year students, are incredibly well suited to, because that allows them to put the skills they are freshly learning into practice on something that's real.
Yeah.
But that's small companies, and then we also find that very large companies are interested in working with universities as well, because if you imagine a very large company that perhaps produces a very complex engineering system, so to take a jet engine for example, where they're always striving in companies like Rolls-Royce and GE and others to make them more fuel efficient. They may have 100 ideas of how to make these engines more fuel efficient, but they only have the resources to look at the top 10 of those perhaps at any one time. So it's actually quite beneficial even for very large companies to work with universities and perhaps give them, you know, one of those sort of challenges that they've identified that's a bit further down their rankings that they don't quite have the resource to put towards yet, and get students to start working on it and generate some ideas and see if that is something they want to run with in future. And it provides a fantastic experience for the students. They get to work with industry, they get to talk to people in business, which really enriches the education they get, and at the same time allows them to do something real and potentially of big commercial value to companies as well. So there's lots of different opportunities to engage, but those are probably the common areas that we see.
Great. In the chat, there's a great point made by Cameron Hussein. So basically referring to the production, he's asking, is the challenge about production as how to make product or productivity and making more items? So I think these are definitely distinct challenges within the production. So how to make the product, but also how to improve the efficiency, that's for sure. So from your point of view, Mark, from an industry point of view, what was the challenge in there? Because on our previous conversations, you talked about the initial development, but also the step change for the productivity increase to address the market demand. So what are your views on that, for that one?
I think it's a very valid point. I think that I think with the sort of technology of CAD systems and their ability to do analysis and 3D modeling, it sort of merges to some extent the aspects of design and prototyping. Our prototyping is minimized by the fact that, you know, we make best use of the 3D tools. And I think it's absolutely fundamental from my point of view that when you're doing the design work is that you have that through the whole process, every single change you make to a design, you're constantly thinking about how you're going to manufacture that product. I think one of the challenges for us is that I become blinkered in our business because we tend to look at that around the processes that you have, and that's a challenge, because there are other processes out there that may be better suited longer term, and that's where you sort of businesses need support and help. But to me, naturally, the sort of working for the manufacturing stage is an integral part of the design. When we're making designs, every time we make a design or an incremental change, manufacture is in there. The pump system is different for us historically. I mean, we're looking for support now from the university on the hydraulic side because that has incrementally developed with improvements in the pump's functionality. The fact that it lowers slower with a heavy load and comes down much quicker with no load, so it becomes efficient and safe. Incremental changes to do that to the design have meant that the design may have become complicated. And it's those kinds of issues whereby, as a company, it's difficult to actually step back and actually say, you know, is there a fundamental change in the design we need to make and start again, because we've made the product complicated by adding sequential design improvements over many years. And that's one of the challenges from my point of view that our business needs the support with. It's that taking the blinkers off and having a fresh pair of eyes and science to support to get us right back on the right track rather than following the route that we keep going down every day because of the experience we already have.
Yeah, okay. So I think that's a great point, Mark. So I think what Rob highlighted and what you are saying is basically these are challenges that can be worked collaboratively. So that brings me to my second question to the audience. So I would like to understand, we would like to better understand what is the current status of the collaboration that the attendees and the manufacturers in the region are having with the university. So I would like to ask, do you work with the research institutes or universities to de-risk the product development? And to be honest, if not, I would like to hear from the chat why and what are the bottlenecks that you see of not being able to work with the universities? So while again the questions are being populated, so Rob, what are your views of the current regional engagement with the universities, and how do you think universities can enable a better engagement with the region?
So I think it's quite mixed in my experience. Different universities have very different sort of top level approaches to engaging with local business and industry. And certainly in the time I've been at Leicester, Leicester has made huge strides towards becoming much more engaged with the local companies, local government, which you know is partly why we're here today. So I think there's perhaps more opportunities than ever before for businesses to work with universities. There are innovation hubs like the one that Leicester's got at pretty much every university these days, and there's quite a lot of sort of government backing for schemes in the areas of knowledge transfer and collaborative research between industry and academia. So there's lots to exploit. I think the real challenge that probably a lot of companies face, certainly when I have talked to businesses, is that some of these opportunities are not very well known about. And it's very difficult sometimes for individual companies to find the right academic to work with. Which is why it's so good to have the Star Accelerator team and the Innovation Hub at Leicester, because they are ideally placed to have those initial conversations with companies. They understand both what the companies are after, and also in terms of what expertise is available at the university. So they work really well as an efficient sort of matchmaking service, and that's a great place to get started. And of course, helping to decipher all of those grant opportunities and things that businesses may be able to apply for as well.
Yeah. So Mark, what is your view? So how do you think the universities can help better or can help the companies, and what do you expect the universities to help to support you in terms of the development of the products?
I think two points to that question. The first one is that as a business, I mentioned earlier that you know, my background is manufacturing, design for manufacture, and so our business has certain strengths, but we also have weaknesses. And if a business identifies where the weaknesses are, and ours might be materials and new processes that we're not familiar with, and then you should search for support to fill those gaps. And for each business, that requirement will be different, and we've identified what they are. And I think that the other one that I think is a personal challenge for me is also that is to enthuse the academics with what you're trying to do, because I've learned over the sort of last 2 or 3 years that that I've needed to put effort into engaging with academics, because I think that they need to be interested in the project for it to be successful as well. And so you have to get that collaboration through. You know, there's projects that haven't progressed yet because academics may not be interested in the technology or what the process is. So there is a matchmaking process, and if when that does work, I think it's quite exciting. And certainly one of the projects we have with yourselves now, with the structural analysis and that development on materials. There are a few people that really engage with it, and it's exciting when it happens, because you can feel a real synergy where everybody can benefit from a project. And I think that's the key point, is a mutual benefit to both the academia and to the relevant industry as well.
Yeah, again, Thank you very much for pointing that out. So that's exactly what we are trying to do, and that's bridging that particular gap to better understand the SMEs needs, the small companies, the startups needs, so that we can address these challenges. And I think this is very interesting to see the question to be answered as 58% no, to be honest. So I think that is a big type of task for us as the universities to nurture that particular collaboration so that we can turn this around or even decrease it to less than 30% so that we can engage with the companies. Because at the end of the day, that's not the only product development, that's the overall supply chain development that we need to nurture within the region, I believe. Okay, so let's do questions. So let's look into the future and let's look into the novel technology. So Rob, I just want to ask you very quickly. So how does the cutting edge technology that you are currently developing would help the companies, would help the businesses, would help the industry? Can you just talk more about that one?
Yeah, absolutely. So there's a few examples in recent years from the School of Engineering. I've already mentioned Dave's wonderful electro-deposited coatings, which I mean, at the very least, you should talk to Dave about these things because he's extremely passionate about them, and it's always an enjoyable conversation. But we have quite a broad expertise in the School of Engineering. So, for instance, one of my colleagues, Rafael Morales, is an expert in control systems for rotorcraft and works with industry to optimize and develop the complex control systems that are needed to get the best performance out of helicopters under various different conditions and requirements. We have colleagues who are working closely with the aerospace industry to develop advanced high temperature materials and to protect those materials under increasingly demanding conditions that you get in jet engines. So very simply, if you want to make a jet engine more efficient, you want it to run hotter. And if you want it to run hotter, you need your materials to be able to survive that. So that's an area we're working in quite closely. And of course, if you look particularly in physics, but also a couple of colleagues in the School of Engineering, there is a huge amount of activity with the space sector, and in helping the space sector to develop, for instance, small scale and very lightweight but very potent power systems for spacecraft and satellites. For instance, my colleague Hugo Williams works quite regularly with the space sector on one of his areas of expertise, which is radioisotope thermoelectric generators, and that's a technology which for instance ESA is very interested in. So there's a huge range of different sort of aspects where our research does link fairly directly with industry. But the other thing I'd stress is that, you know, a lot of people on this call may be thinking, well, hang on a minute, those are either totally unrelated to my product or they're a totally different level to what I'm interested in. And that's why the other aspect of what universities have is so valuable in terms of our students. Because our students are, again, like us, like academics, they have a range of different interests, whether it's in mechanics or whether it's in electronics or whether it's in control systems, aerospace, you name it. Someone is going to be keen to look into that. And they are at a stage where they want to engage with a really applied project. They want to engage with something where they can understand and they can see the benefits that it's likely to achieve within quite a short time frame. I mean, at the end of the day, they work on a project for a year, and you know they would like to be able to understand how that's going to be beneficial within that time frame. So we can do lots of technical optimization work with our students. And we've got a number of good examples in recent history. You know, a couple of years ago, one of my project students helped a company to develop an on-site test rig for hydraulic valves. And in doing so, basically saved the company probably sort of £20,000 worth of professional design engineer time. And produced a design for a test rig, which now saves that company something like £10,000 a year. So, you know, it's a huge sort of gain for very little sort of input, if you like, from a company's point of view. So it's very low risk in that regard. We also have students who specialise in engineering management. So one of the sort of leading programs at the University of Leicester is a postgraduate one, which is the MEM, is the Master in Engineering Management program. And students doing projects on that program are interested they're interested in business strategy, they're interested in cost engineering, they're interested in lean processes and sustainability. So they can help companies by doing things like sustainability assessments and trying to understand how companies can change their activities or their management processes to optimize and to reduce their environmental footprint. So there's a huge range of things that we can potentially do, and honestly, the first place to start is if you've got a challenge, if you've got an idea, talk to us, and we will probably know someone who can help.
Exactly. And I just want to pick up one question or one comment from the chat. So Tony Mesu is saying that I think there are other factors that dampen SMEs working with academia. So particularly he's referring to SMEs not having lack of funds. But I think that's something that we can work through, because we can navigate as the university, as the research enterprises. We know these funding routes and we can navigate through them. Although they may be too complex, as Mark mentioned initially, they can definitely be addressed and then identified rightly for the right SMEs, right products. We just need to understand what the product is. So there needs to be an incentive from the business to innovate so that we can understand and we can find and support, I believe. And graduate students, that's definitely a key area. So Mark, before we close, I just want to ask one last question. We are already running out of time, but that is a quite important one. So you continue innovating. You highlighted that a lot. So what is next for your company and your product? So you mentioned all your development, but what is next? How do you want to grow your company, and what are the roles that you see a collaboration plays in that particular roadmap?
I mentioned earlier that sort of van mates. It's sort of diversifying and moving into lorries. Thought about changing the name to Lorry Mate, but we've already registered the trademarks for Van Mate, so it's staying there. Yeah. And so it's in two parts, as we've talked about in the past. We've got the ongoing development. We get regular inquiries from customers who say, Van Mate's great, can it lift a small pallet? And so we then develop attachments that can lift a pallet. Have you got one with a crane attachment so I can lift hydraulic power packs into a vehicle? And so there's an ongoing development process for developing new trolleys. We've got a trolley that can go up and down curbs for the home delivery. We've got attachments for lots of different applications, and so that's an iterative one. And that's what we're good at, because we know our product. The other part of it is the one I alluded to earlier, which is the stepping back and looking at the product fundamentally and saying, we need to make the product to lift more weight. We need the product to lift higher. We need the product to lift mass further away from the mast, and make it lighter.
Yeah.
I think somebody has a microphone turned on.
Yes, I think there is a microphone. So if the audience can turn off their microphone and videos, that would be really appreciated. Thank you.
And so it's that step change, and I think that we use very high tensile steels for the mass system now. They have a real benefit because they don't suffer fatigue in the same way as some other materials. You can create complex parts in terms of a laser cut flat pattern, and then we've adapted techniques to create very precise folded products. Yeah. But they do suffer from flexibility, and there's a limit to what they can do within the weight constraints. And so we need to look at other materials, and we've alluded to aluminium, and it's got some advantages and disadvantages. And academics have already suggested other materials as well, which I wouldn't have even considered. So that step change to get small companies to think outside the box and at least explore other opportunities is the bit where it's easy to become absorbed in what we do. And I've become absorbed, and it's been interesting to hear different suggestions, because it makes you think differently. And we won't make the step change we need unless we get that inspiration that's outside the box that we live in. And I think that's where the biggest benefit comes from my point of view.
Yeah, great point, Mark. And I think on the chat there is also a relevant point made by Cameron about that. So Cameron is saying that there has been a study conducted and that it has been found that there is an impact between good management and good productivity. That's definitely a key, and SMEs are less likely to have taken on board advanced manufacturing practices because they are diving into the day-to-day type of activities, and potential great impact can be then created for the SME manufacturing. So basically, he's again alluding to what you have mentioned, Rob. So again, engineering management school and management KTPs, management knowledge transfer partnerships, are definitely can be key of unlocking that productivity challenge for the university, for the companies. So I just want to open up the chat and the question for our panel to the audience in the upcoming 1 or 2 minutes. If there is any question, please join in via the chat or raising your hands. Howard.
Can I just make one very quick comment, Mark, with regard to your product development, of course, because I talked very briefly about mission creep, and there's a fine dividing line between developing your product before it's in manufacture and continuing to develop the product after it's in manufacture. And of course, it's that fine dividing line. So adding extra features to a product that you've got, that's part of the process. But what you've got to do really is to restart the development process and follow through the normal route of product development as if it was new, just shortening the timescales because you've already got something in production.
I think you're absolutely right. I mean, and when I talk about making additional features for a product, when we designed VanMate, the VanMate is designed with a mass system that's slotted so that it was purposely designed initially to be able to put in more attachments on it later. In fact, we start off with this with a big car parts distributor for the drums, and it was the ops director of that group that said, "Can you lift engines?" And we'd not thought about it, and we thought it meant out the car. And I said, "Well, you can go down to Machine Mart and buy an engine crane for less than we can make one." And he said, "No, I mean for lifting engines in stillages, for delivering reconditioned engines to garages and picking up the one that's come out of the vehicle and bringing it back." And I said, "Of course we can do it because we've designed it with a slotted mass system so that we can put any attachment on it." So in terms of you're absolutely right in terms of revisiting, but in terms of the VanMate system, it was developed with the ability to adapt and put other attachments on it right from phase one. The incremental part has been that we started with something that worked because we had to, because we'd found a customer application and the customer was chomping at the bit to actually get products in place. This system replaced 3 separate pieces of equipment, costing 3 times the cost, including an hydraulic crane system in the back of the van, which was heavy and couldn't deliver the drum to the customer. And so where we started was a product which was heavier than it needed to be, but met the regulations and could do the job. And then the evolution then is to sort of gradually strip weight out through analysis and repeated prototyping to get it down. But we're already down, and we've maxed out on the tensile of the steel, we've maxed out on the structure and the design, and we've reached a limit. And you're absolutely right now, Howard. We need to take a step back and say, we need to revisit how that product is actually constructed from ground up, because we're not going to go any further with the product as it is now without making a step change.
Yeah, great point. Okay, so I think definitely I hope you can stay to the networking session later on. We can continue this discussion in the networking session, but I would like to thank Mark, you and Rob for joining us today and enlightening us about your journey in product development, Mark, and the opportunities within the university for helping companies for product development. So thank you very much for that.
Thank you.
Thank you.